Right now, as you sit here, something is leaving. Not from this room, from the universe. Hundreds of millions of stars just crossed a line they will never come back from. They didn't explode. They didn't die. They were pushed, shoved so far away that their light will never reach you again. Not in 1,000 years, not ever. And here's the part that should keep you up tonight: you didn't notice. Nobody did. So the question is, how much has already disappeared that we never even got to see? That question has an answer, and it's worse than you think. But first, you need to understand what's doing the pushing, because it isn't gravity, it isn't motion. It's space itself, and it's been caught in the act. In 1998, two teams of astronomers set out to measure how fast the universe was slowing down. That was supposed to be a boring confirmation. The Big Bang flung everything outward, gravity pulls everything back, the expansion decelerates. Textbook. Saul Perlmutter's team at Berkeley and Brian Schmidt and Adam Rees's team in Australia both used the same trick. Type Ia supernovae, dying white dwarf stars that always explode with nearly the same brightness. Perfect cosmic rulers. Measure how dim they look, calculate how far away they are, plot the deceleration curve. Routine. Except the curve went the wrong way. The distant supernovae were dimmer than they should have been. Not by a little. The universe wasn't slowing down, it was speeding up. Something was pushing the cosmos apart, and it was getting stronger. They called it dark energy. It makes up roughly 75% of everything that exists, and to this day, nobody knows what it is. Perlmutter, Schmidt, and Rees won the Nobel Prize in 2011, not for finding an answer, for finding the question. Now here's what that acceleration actually means for you. Picture the observable universe as a sphere around you, 46 billion light-years in every direction. 2 trillion galaxies. Sounds vast. But dark energy has already locked 94% of those galaxies away. Their light still reaches us, the old light, the light they emitted billions of years ago, but nothing they send out from now on will ever arrive. Of the 2 trillion galaxies you can photograph tonight, only about 6% are still in play. The rest are already ghosts, and with each passing year, hundreds of millions more stars slip across that boundary. The cosmic event horizon. Think of it as a one-way door written into the geometry of space. Once something crosses it, no signal, no ship, no technology however advanced can ever bring it back. It's not that the galaxies are moving through space faster than light. Space itself is stretching between you and them, adding distance faster than light can cross it. And the rate is increasing, so here's where the math turns cruel. In a few tens of billions of years, every galaxy outside our local group, that's a small huddle of about 50 galaxies gravitationally bound together, the Milky Way, Andromeda, a handful of dwarfs, will have redshifted into invisibility. The sky will go dark, not because the stars died, because the universe carried them away. But wait. Don't the Milky Way and Andromeda have their own story? They do. In roughly 4.5 billion years, right around when our sun starts dying, Andromeda will crash into the Milky Way. 100 billion stars, threading through another 100 billion stars. Almost none will actually collide, stars are that far apart. But the two galaxies will merge over several billion years into one giant elliptical blob, nicknamed Milkomeda. Our night sky will transform from a thin band of light into a uniform blaze of stars in every direction. Beautiful, and the last island of light we'll ever see, because after that merger settles, Milkomeda will be alone. Every other galaxy gone. The cosmic microwave background, the afterglow of the Big Bang itself, that faint whisper of radiation that currently bathes the entire sky, will have stretched so thin, its wavelength longer than the visible universe, its intensity faded by 12 orders of magnitude. Undetectable, even in principle. Now, remember the bait? I told you a paper proved something terrifying. Here it is. In 2007, Lawrence Krauss and Robert Scherrer published a paper titled The Return of a Static Universe and the End of Cosmology. It won the Gravity Research Foundation's top prize and landed in the Journal of Relativity and Gravitation. And what it says is this: the 3 pillars of evidence for the Big Bang, the Hubble expansion, the cosmic microwave background, and the primordial abundance of light elements, will all be erased by dark energy. Every single one. No distant galaxies to reveal the expansion, no CMB to map. No external reference points to deduce where the light elements came from. A civilization born in that era, say, 100 trillion years from now, orbiting one of the last red dwarf stars, would do brilliant, careful, honest science. They'd map their galaxy, they'd study their stars. And they would rationally, correctly, inevitably conclude that they live in a single, static, eternal island of light surrounded by infinite nothing. They would have no way, none, to discover that a Big Bang ever happened. That 2 trillion galaxies once filled the sky, that the universe was ever anything other than what they see. They wouldn't be stupid. They wouldn't be ignorant. They'd be exactly as rigorous as we are, they'd just be wrong. Because the evidence would be gone, and those last red dwarfs, they are the universe's final act. Red dwarfs make up 75% of all stars. They burn so slowly, sipping hydrogen like a candle in still air, that the smallest ones will last 10 trillion years. That's 700 times the current age of the universe. Not a single red dwarf born since the Big Bang has died yet. Every one of them is still a baby, but even they run out eventually. Around 100 trillion years from now, the last red dwarf will exhaust its fuel, shrink into a blue dwarf, then fade into a white dwarf, and over incomprehensible eons cool into a black dwarf. A dead cinder the size of Earth, floating in absolute darkness. No heat, no light, no structure, no information. The universe doesn't end with a bang or a whimper. It ends with forgetting. Now, here's the punch. Krauss said something in that paper that nobody quotes enough. He said, "We may feel smug in that we can detect a host of things future civilizations will not know about." And then he said, "But by the same token, this suggests we wonder about what important aspects of the universe we ourselves may be missing." Read that again. If the universe is erasing evidence of itself from the future, what has it already erased from us? What signals faded before we built our first telescope? What structure dissolved before the first human looked up? We assume we're at the center of the story, that we live in an era of maximum information. But that's exactly what those future astronomers would assume too, and they'd be wrong. So here's the answer to the question I asked at the beginning. How much has already disappeared that we never got to see? We don't know, we can't know. And that's not a gap in our technology, it's a feature of the universe. You are alive in a window. A brief, unrepeatable window when the light from 2 trillion galaxies is still reaching this small planet. When the afterglow of creation is still warm enough to detect, when the evidence still exists. Before you were born, some of it was already gone. After your species is gone, all of it will be. The